Okay, here we go. Are you ready? All right. Fantastic. So, for those of you who were gone, remember last Tuesday, we skipped this part because I think we played a game or something. Okay, so I skipped this. The other classes did it, so they're ahead of us. So I'm going to go through this with you quickly today, kind of on a streamline, and then I'll let you guys hopefully have maybe tomorrow to work. This is 5th hour, right?
Yeah.
So I will see you tomorrow. Yeah. So maybe tomorrow to work, or actually tomorrow we'll probably move on. If we're in school, we'll see what happens with the weather. Okay, so looking at lecture 17. If you remember lecture 16 talked about quadratics, so this 17 is just more with quadratics. And really there's just a couple things we want to look at. Remember a couple things, so this is just kind of a review. We know we have the quadratic formula, x equals negative b, and so forth. Okay, so we had that quadratic formula, and then remember we talked about the discriminant, correct? So first of all, before we talk about that, number one, remember you have to have it in standard form. Ax squared plus bx plus c equals 0. So a lot of times on homework or Delta Math, it's going to give you problems something like, negative 3x squared plus 8x plus 10 equals 4x squared minus 1. So before you do anything with quadratics, what do I have to do first? Well, I'm going to have to get everything to one side, right? So I'm going to have to subtract the 4x squared, add the 1, so that I would have everything on one side and 0 on the other. So before you do anything, that's the first thing we have to do, okay? You good with that? Okay, number 2. Then, if you remember the discriminant, what is the discriminant exactly? Do you know what the discriminant is? It's part of this up here. No. It's everything underneath the radical. It's just b squared minus 4ac. Notice I'm not including the radical. It's just the expression underneath the radical. And then remember, if b squared minus 4ac is positive, or sometimes we say greater than 0, that tells me that there are 2 real answers. If that discriminant is negative or less than 0, we know that there's 2 complex answers. And remember, if it's equal to 0, then there is 1 real answer. Okay. So the discriminant is going to kind of tell us what our answers are going to be. Okay, now, I want to look at some different ways of solving it using the quadratic formula, but I want to show you one kind of as a warning. I'll put it right here. A little bit as a warning. If I give you something like x minus 2, times the quantity x plus 5 equals the quantity x plus 4 times the quantity x minus 2. Now, if I were to give you that particular problem, what might be something you think about doing first to solve that particular problem? Foiling out, correct? Okay, so a lot of people will say foiling, and that's actually what you want to do. You want to go ahead and multiply this out because think about this. You see, well, what do they have? What do they have in common on both sides? Okay. What else do they have in common on both sides?
Oh, wait. They have x minus 2.
They both have the expression x minus 2, and you might think of through this and say, oh, well, let me just go ahead and divide. Don't do this. I might think about, let's go ahead and divide by x minus 2 on both sides. If that happens, these cancel, correct? And then I'm left with x plus 5 equals x plus 4, and I have a problem. Don't write this down. Okay, this is wrong. Is there a number, any number in the world, where if I add 5 and add 4, they're still going to be equal? No, that's impossible. That's an impossibility. There's no solution to that. So what I've actually done by dividing by x minus 2, I've actually eliminated my answer. Okay? So we don't want to ever divide by a variable. Let's get rid of that. So we want to do what you said first, is I do want to go ahead and FOIL it out. Okay? So on this side I have x squared plus 5x minus 2x minus 10. I'm going to blow my nose, so go ahead and FOIL that side as well, the other side. So on this side I'm going to have x squared minus 2x plus 4x minus 8. And then when I combine like terms, I have x squared plus 3x minus 10.
Excuse the interruption, can I have Brianna Porter for checkout? Brianna Porter for checkout, thank you.
Okay, so I have x squared plus 3x minus 10 and x squared plus 2x minus 8. And what do you notice is on both sides?
X. X squared.
I have an x squared. So if I subtract x squared on this side, and I subtract x squared on this side, notice I'm not dividing. We don't want to divide. But if I subtract, I'm left with 3x minus 10 equals 2x minus 8. And then what would I do to solve for x? Well, I'm going to go ahead and, so this is like my linear problem from the other day, lecture 16. Subtract 2x, add 10, and what I'm left is x equals 2. And do you notice anything about the answer and what I started with? Is there a way I could have gone from this and just given me the answer?
X negative 2, the x minus 2 is?
Yeah, that part earlier we talked about dividing by x minus 2 on both sides. That actually eliminated my answer. That actually is your answer. So I could have just said x minus 2 equals 0, x equals 2, and that would be true. 2 minus 2 is 0, 2 minus 2 is 0, 0 equals 0. Okay. So when I see these, don't divide by a variable. Go ahead and distribute them out, but also you can see this actually is your answer. Okay. So a little bit of a warning, be careful with that. Now, what we're going to deal with is we're going to deal with that discriminant, that part of the radical, that part of the formula right here. Right here. There are 7 possibilities for this discriminant. Okay? So we're going to look at, this is the crux of this lesson. We're going to look at 7 possibilities for the discriminant. Okay? 7 possibilities for the discriminant. Okay? Hopefully you see a pattern too as we write this. So category number 1, if you will say Roman numeral 1, actually I'm going to use capital letters so that I can number the possibilities. Capital letter A, b squared minus 4ac is greater than 0. Or we could say it's positive. Now, what did we say? If the discriminant is positive, how many answers do I have and what type? Remember, if b squared minus 4ac is positive, I'm going to have 2 real answers. So, what that's going to look like is, when I have my equation, it's going to cross and have 2 answers here and here. Or it could go the other way. Okay? So, one possibility is, remember I said there's 7, right? One possibility is that we would have something like 3 plus or minus the square root of 16 over 4. So one possibility is the discriminant is a perfect square. Okay. This is probably involves the most work. The discriminant is a perfect square. Because when I look at that discriminant underneath that radical, it's 16. What's the square root of 16? 4. So then I know then that I have 3 plus or minus 4 divided by 4. And I can go ahead and actually solve that and get my two answers. I would say 3 plus 4 over 4 and 3 minus 4 over 4. So I would get 7/4 and -1/4. And I would get my two answers. And that actually is the most work of any of them, besides possibly reducing radicals. So that's one possibility where this discriminant is a perfect square. Messiah, you good with that one? Almost. Okay. The next possibility is 3 plus or minus the square root of 17 over 4. And this is where the discriminant, I'm just going to put capital D for discriminant, okay, is a non-reducible radical. 17 is not a perfect square. 17 is actually prime. We can't break it down at all. So the discriminant is a non-reducible radical, just the square root of 17. Okay? This is probably the easiest of all of them because that's your answer. We're going to leave it just like that. So we start off with the most work, and we end up with the second one, the least amount of work. Non-reducible radical. Do you understand what I mean by non-reducible radical? Can you know what I mean by that? Non-reducible radical?
You can't reduce it.
That was deep. Okay, it's something like the square root of 60.
5.
The square root of 60. Can that be broken down? Okay, so square root of 6, square root of 10. Let's go with the square root of 4 and the square root of 15. Because what's the square root of 4? 2. Oh, it's a perfect square goes into it. It's non-reducible is when a perfect square does not go into that number. Okay, and remember the perfect squares, right? 1, 4, 9, 16, 25, 36, all those. All those perfect squares. If none of those go into the number perfectly, then it's non-reducible. Okay? And when that happens, you're just done. There's your answer. Okay? So then number 3 would be something like 3 plus or minus the square root of 18 over 4. In this case, the discriminant is a reducible radical. So I can take that square root of 18 and I can break that down. I have a perfect square that goes into it. Okay? They keep emailing us updates about the dismissal.
Are they constantly changing things?
They changed things 2 or 3 times. I just keep watching my email to see if anything pops up. Okay, so what does the square root of 18 reduce to? What's a perfect square that goes into 18?
4?
4 does not go into 18 anymore.
8,
8 is not a perfect square.
2,
2 is not a perfect square. There's your perfect squares. 1, 4, 9, 16, 25, 36, 49, and so forth.
that goes into 1.
Yeah, that doesn't help us. 9.
Oh.
You kind of beat all around it.
Oh.
So the square root of 9 times the square root of 2. Okay, what's the square root of 9? 3. So this is going to be 3 radical 2. So to break down that radical. So then I end up with 3 plus or minus 3 radical 2 over 4. And there's my answer. So really all I have to do is take that and break it down. And we'll do a little bit more of that when we talk about radical expressions in lesson 18. Actually, 18, 19. And I told you there was how many possibilities?
Infinite.
No. 7 possibilities, right? 7 possibilities for the discriminant. I just covered 3 of them. Okay. So the first one is it's a perfect square. This is the nice one because we get 2 actual answers. Non-reducible radical, I'm done. If it's reducible radical, I've got to break it down. Okay?
Excuse the interruption. Isabella Day, can you please go to room 303? Isabella Day, please go to room 303. Thank you.
Okay, you're good with those 3. Now, I'm going to make a column. You probably can't do it in your notes. You might just continue down. But I'm going to make it here so you can see the connections between them. Okay? So the second possibility is if b squared minus 4ac is less than 0, or we would call that negative. And you're going to see some connections between the 2. Now, if it's negative, how many answers am I going to have? And what type? 1. No. It's negative, I'm going to have 2 complex, right? So what that graph is going to look like is, it's going to be up here. I'm going to have no x-intercepts. Not going to cross the x-axis. Okay, so we're going to go through our possibilities again. Number 4. If it is a perfect square, so I would have 3 plus or minus the square root of negative 16 over 4. And the difference being, here I have negative 16, not positive. So what would be the square root of negative 16? Are you with us or are you behind us a little bit? Oh, you're right on. It's very good. So what would I do with it? What's the square root of negative 16?
Negative 4.
So close. No. 4, then what's the square root of negative? Because remember, you think about this as negative 16, negative 1 times the square root of 16. This is 4. What's that? It's a letter. It's what? Cam, do you remember what letter that is? The square root of negative 1?
I.
It's I. Okay, you remember that now, the imaginary? Okay, so in this case, you would simply have 3 plus or minus 4i over 4. So it's the same thing I have here. The only difference is now I have that I in there. And then there's nothing I can do with that, so that is my final answer. So let's see the difference between positive and negative. The difference is I'm going to have a little I there. Okay, you're going to see that a lot. So the next one, number 5. I would have something like 3 plus or minus the square root of negative 17 over 4. So here I had a perfect square with a negative. Here I have a non-reducible radical with a negative. So what would I do?
Keep it the same, but put an I at the end?
Exactly. Well, I'm going to put it in the middle. I'm going to make 3 plus or minus. We put that I in front of the radical. 17 over 4. Do you understand why I put it before, not after?
No.
No, not on door.
Yeah.
Think about why I might do that.
to have the 17 a prime number?
Sorry, I can't hear my band.
You have practice?
No, they canceled it.
Well, I know basketball is practicing like right now.
Yeah, they moved basketball practice now. You haven't happened to see Lucas Western, have you?
I haven't seen the one. Sorry.
Alright, thank you.
So why do I put it here rather than at the end?
Keep the 17 a prime number or real number?
Well, it's really just a notation thing because this is going to be different from that. The I is the I underneath the radical or is it outside? So avoid that discrepancy, we just put it in front. Because the I should not be under the radical. So we just always put it out front. Alright. So, but once again, we just change it to the I out front and we're done. Okay, number 6. 3 plus or minus the square root of negative 18 over 4. Now this is going to be what? So what's the difference between the negative 18 and the positive 18? Simply going to be exactly right. And where am I going to put the I? I'm going to put it right between the 3 and the radical. Yep. I'm going to go 3 plus or minus 3i out front, radical 2 over 4. And the only difference between the positive and negative is I'm going to have that I in there. The only difference between these two is I'm going to have that I. The only difference between these two is I'm going to have the I. But the nice thing about this one is I don't have to simplify. I don't have to break it down. Because you can't combine that. Okay? All right. So those are 6 possibilities, right? How many possibilities did I tell you we'd have? 7. So we got to go with capital letter C. What if b squared minus 4ac equals 0? So for example, I have 3 plus or minus the square root of 0 over 4. Well, what is the square root of 0? 0. And 3 plus 0 is the same thing as 3 minus 0. So it's like this isn't even here. So my answer is just 3/4. And if it equals 0, well, it just, the radical goes away. Okay? So when it comes to the quadratic formula, and we deal with that discriminant, these are the possible answers we're going to do. There's only 7 possibilities. Perfect, positive, non-reducible radical, reducible, negatives, or 0. Okay, and also, by the way, one more concept we need to review. If it's positive, it touches it twice. If it's negative, it doesn't touch the x-intercept at all. What if it's equal to 0? How many times will it touch the x-axis? Once. It's going to actually rest on the x-axis, which means you will have one answer. One real answer. And that's what our chart said back here. We have one real answer. Oof. Okay. All right, so before I end for the day, because we're almost done, any questions on any of this? Would you like to see an example of something? You said no? Camden's good? You're good? I'm done.
Excuse the interruption, can I have Nevaeh Gatson for checkout, please? Nevaeh Gatson for checkout, thank you.